All right, hello class. This is Dr. Cooper. This is chapter 12. We'll be covering liquid, solids, and intermolecular forces. So let's review the states of matter. There are three major states of matter. First, there are solids. Solids can be broken down into two classes or two descriptions. For the solids with very organized, regular geometric patterns, we like to classify these type of solids as crystalline. And solids that have, you could say, irregular patterns or highly disorganized geometric organization, we call these type of solids as amorphous solids. Okay. The second state of matter are liquids. Most individuals in the class are familiar with the liquid state of matter. And lastly, there's the gas state of matter as well. Okay, very briefly, let's define the three different classes here. Solids. In solids, the individual molecules are held together really tightly. They have very defined shapes and volumes. For liquids, the molecules or the individual molecules in a liquid are moderately held close. Okay, so they don't have a defined shape, but they do have defined volumes. And this moderately close interaction between the molecules and liquids allow those molecules to be poured or have a flow attribute when they are transported from different vessels or containers. And lastly, gases, their individual molecules are very far away from one another. All right, so they don't have any defined shapes nor defined volumes. The mere fact that these molecules are far away from one another, all right, there's a lot of empty space. This allows gases to be highly compressible. Okay, so let's talk about phase transitions. And the way that we define a phase transition is moving among the different states of matter. All right, so moving among the solid, liquid, gas, or really in any order. Okay, so you must overcome or gain attractive forces among those individual molecules to be able to move among phases. All right, so this is a nice diagram showcasing that. In a solid, if I heat it, I can move from a solid to a liquid phase. Okay, and if I continue to heat that liquid, or if I reduce the pressure, I can move from a liquid into a gaseous phase. All right, I can take a gas and increase pressure or cool it to a liquid, and if I continue to cool, I can regenerate back that solid. So whenever I move among a different state of matter, we just call it a phase transition. Okay, we're trying to learn now that heat can overcome these attractive forces, but cooling can force attractive forces to persist. All right, and either overcoming or gaining attractive forces is going to allow us to move among different phases. Okay, so attractive forces are made possible by intermolecular forces. Okay, so really quickly, let's talk about the word intra and inter. Okay, so attractive forces are made possible by intermolecular forces, not intra. All right, intermolecular forces are, when we use the word inter, we're really talking about interactions among separate individual molecules, and intra will be forces among the same molecule. Okay, so right now we really are interested in these intermolecular forces. So there are three intermolecular forces present. All right, the first is this London dispersive force. This is also referred to as these van der Rohe interactions. The second force are dipole-dipole forces. And lastly, hydrogen bonding is the last major intermolecular forces. Okay, so if we go from 1 to 3, hydrogen bonding will be the strongest of the forces, and the London dispersion will be the weakest force among the intermolecular forces. Okay, so London dispersive forces are present in all molecules. All right, and this is the weakest attraction. So students should keep in mind that every molecule present would have a London dispersion force. The second attractive force, this dipole-dipole, is only present in molecules with polar bonds or with these permanent dipoles. Okay, So if we have a polar bond, you're going to have a dipole, and this is will allow us to have these dipole-dipole interactions. And lastly, the hydrogen bonding is one of the strongest attracting forces we can have. All right. And to have hydrogen bonding, I have to have a unique scenario. I have to have a hydrogen bond donor and acceptor. All right. So a hydrogen bond donor is really a hydrogen that's attached to an extremely electronegative atom. All right. And these atoms are typically nitrogen, oxygen, sulfur, or any halogen. And don't forget the halogens are group 17 in the periodic table, so that can be a fluorine, chlorine, bromine, or iodine. All right. And hydrogen bond acceptor is just an atom that has some type of electron density, right? So that means it can be an atom with a lone pair or a negative charge or a very strong partial negative charge, right? Those hydrogen bond scenarios where I have a hydrogen bond donor and a hydrogen bond acceptor allows me to have hydrogen bonding.